Okay, guys, I get to the next page, and now it looks like I'm going to use the east side, who are normal people apparently, and the west side of the class who were weird. I don't know why I was calling them normal and weird. It sounds very judgmental. I'm glad I've matured. I don't do stuff like that anymore. But hey, I'm going to go to my calculator, and I'm going to put that data in the calculator. So I've pulled up Canvas on my computer, and so I'm going to go to Stat and Edit, and I'm going to go up and hit Clear to get rid of that fake data that I just put in there. And so the first one I'm going to do is for the east side regression line. So east side, that was normal people. And so here are my x values. 8, 10, 9, 9.5, and 8.5 were the shoe sizes for the east side normal people. The steps went 63, 60, 64, 61, and what's this last one? 60. Okay. Then while I'm at it, I'm going to put the other ones in list 3 and list 4. So shoe sizes go 8, 10, 9, 9.5, and 8.5. They're the exact same. So watch this cool trick. I'm going to go up one. I'm going to hit enter. And then I get a cursor at the bottom. I'm just going to type in second and 1 for L1, and I'm going to get the exact same numbers that I had over there. It's not my first day with the calculator, people. So then I want my y values, the number of steps for the west side, which apparently are weird people, and they go 50. I mean, you could just type them in if you want, but when the calculator has tricks, use them, you know what I mean? 50, and then 65, 52, 60, and 59. I could look at the scatter plots again. I can tell you want to look at the scatter. Okay, we'll look at the scatter plot. So this first one is for L1 and L2, and that's for the normal people. I go second and y equals. I hit enter to turn the plot on. I actually turn the plot on. Now I'm going to go to the scatter plot, which is the first one. I'm going to hit enter, and I want my x list to be list 1, and I want my y list to be list 2. Now you made a scatter plot of this the other day. So I'm going to hit zoom N9 for stats, and there's my scatter plot. It's a weak form, and it's linear. Weak form, and it's linear. Okay, let's look at here. We'll even write this right over here. We'll go weak, negative. I said linear. I'm so dumb. Weak, negative, and linear. Okay, so let's look at the other one. I hit second and y equals. I'm going to hit enter to turn the plot on, but this time I'll go L3 and L4. L3 right there. L4 right here, and I'll hit zoom 9 again, and I'll see the other one. Now this one's a little bit stronger, so I'll just write stronger than the last one, and this one is positive. So when we did correlation, we got a negative correlation and we got a positive correlation. Okay, here we go. I want to know the actual line, so I hit stat, go over to calc, and go all the way down to number 8. And I'm going to do this for list 1 and list 2. It's already there. So I go down and I hit calculate, and it gives me an equation. So I'm going to write y hat is equal to, you got to know to put a hat, 70.6 minus 1 x. Okay, now you should know this. Stats people are weird. They don't just put x's and y's. Sometimes they put the actual variable in there. So, okay, so I'm going to go number of steps. Instead of a y variable, I'm going to call it number of steps. And are you ready for this? I'm going to put a big giant hat over the top of it. Is equal to 70.6 minus 1 times shoe size. You will actually see equations in this book for stuff you have to do for homework and whatnot where they actually have the words written out there. Okay, let's go do the second one. So I'm going to do stat. I'm going to arrow over to calc. I'm going to go down to number 8, and I'll do a linear regression. This time it's for L3 and L4 because that's where I put my data. So I go down to the calc menu, I hit calculate, and here's my other equation. Y hat equals 1.4 plus 6.2 x. Now, doesn't it make sense to you that if I have a weak negative association, that I'm going to have a negative slope? And if I have a stronger positive association, I'm going to have a positive slope. Okay, the other way I could write this, of course, is number of steps with a big hat on it is equal to 1.4 plus 6.2 times shoe size. It's just ridiculous to put words in the middle of an equation, isn't it? That's embarrassing. Okay, this is a huge interpretation for us. It will be on your test. It will be on the AP exam. You need to know this. You need to know this in life, people. We're going to interpret the slope. It's not rise over run. Unlike algebra classes, slope is not going to be referred to as y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Or even rise over run. Every time you interpret slope, it goes like this. As the explanatory variable increases by 1 unit, the response variable, I guess I should say variable in here, so I'm going to abbreviate that, increases by slope. That's what a slope is. Generally, you go an entire rise over an entire run, but slope is really how much do you go up if you go over 1? That's what slope is really about. So my Larson example for the normal people, interpret the slope. The normal people, that is the east side, that's this first one. I have a slope of -1. Ready? As shoe size, which is the explanatory variable, increases by 1. So if you get, a bigger shoe, a person with one size bigger is the shoe, the number of steps. Now what happens to the slope? It's -1, decreases by 1. As shoe size increases by 1, the number of steps decreases by 1. You see it? Okay, interpretation for y-intercept, this sometimes is just plain old stupid. So we kind of stay away from it. Okay, a y-intercept, what does that mean? It means that you're on the y-axis, so it's the point 0, y. It's where x equals 0. Think about the shoe size situation. Nobody's wearing a size 0 shoe. Okay, here's an interpretation of a y-intercept. The value of the response variable when the explanatory variable is 0. Many times this interpretation is nonsense. Okay? For weird purple, okay, I'm tired. For weird people, that's, let's see, that's the west side. It's right here. I'm going to interpret this y-intercept of 1.4. Ready? 1.4. Okay, when a weird person, again, so judgmental. I'm beyond that. I'm a better person nowadays. When a weird okay, I just wrote when a weird people. Oh man, am I tired. Okay, when a weird person's shoe size is 0, we predict that they will take, you ready for this? Are you ready for this? Go up here. This is the y-intercept. They will take 1.4 steps to get down the hallway. None of that makes any sense. It's absolute nonsense. So the weird people, that's the west side, okay? That's the positive slope. Ready? That's the positive slope. I think that's this one. So if I'm going to make a line out of this, which I did, I could put this line on here, but let me hit the trace button. This bottom is that's a person with 8 as a shoe size, and it takes them 50 steps. So if this line keeps going, and I'm talking about putting a 0 in for x, I'm going to be way down here. And so I'm actually predicting that if I have a shoe size of 0, which makes no sense at all in the first place, we predict that they'll be able to get all the way down the hallway with 1.4 steps. Utter nonsense. So what we'll do is we'll focus on this slope. That's why I have an asterisk here. When we make this line that's supposed to go through this scatter plot and make sense to us. In fact, hang on, give me a second here. I'm going to go back and I'm going to put that line on this graph. That's this one right here, right? So I'm going to go to y equals, and I'm going to put 1.4 plus 6.2x, and I'm going to hit graph. And you can see that that line does, in fact, go right in between all those points, right? And then if you look at it, if I put in a 0 for x, I get 1.4 for y. That particular prediction makes no sense. I wonder if I could, let me, hang on, I'm going to change the window while I'm just playing around here. I'm going to change the window so that the x minimum is -1. Okay? And the y minimum, I'm going to make 0. That's not what just happened. I just did something stupid. So I'm going to go back up to 12. I'm going to go down to the y minimum and I'm going to make it 0. And the y maximum will make it 70. I'm going to change the scale here because if it's a scale of 1, I'm going to have 70 marks on my calculator and it's going to look all weird. So I'm going to make that 10 so the scale goes by tens. 10, 20, 30, 40, 50, 60, 70. So I'm going to hit graph. You see my scatter plot is way up there. You see the line goes through it. But when I made that prediction for x equaling 0, I'm making a prediction way over here, which makes no sense with the data we got. That's why it's absolute nonsense. But the slope is what it is through these points, so the slope makes more sense. So like I was saying a minute ago, this part is good for us. It's going to describe what's going on within the scatter plot. Frequently, this part, not so much. Every now and then it's important, but for the most part, slope is really the hero of the day. Go to the next page.